everybody, it's Olivia, and I'm going to be showing you how to find the axis of symmetry, X-Intercepts, and Vertex of an ax squared plus bx plus c type equation with a parabola, a quadratic function, essentially. Okay, anyways, so I picked a sample equation from the internet, and it is y equals x squared minus 2x minus 3. So let's set it up. Okay, so the formula to find the axis of symmetry is what we're doing first, is negative b over 2a. So that is a good thing to remember when solving these. Okay, so I'm going to show you how to set up the equation now. So with y equals x squared minus 2x minus 3, a is 1 because there's not a coefficient with this x squared, so it's 1 because 1x squared is the same as x squared. B is negative 2 because see there's a negative 2 next to the x, and then c is negative 3 because it's minus 3. So you're going to set it up like this. You're going to substitute the letters in this equation for the numbers in your equation that you have. So I have negative 2 over 2 times 1, and this is a negative fraction. So that is negative 2 over 2, because 1 times 2 is 2, negative 2 over 2. So I changed that to positive 2 over 2, because this overrides this. And so then your vertex, or not your vertex, your axis of symmetry is going to be 1. And what that means is that in your final thing, your axis of symmetry is this little dotted line that marks the center of your equation. So if you cut it in half, it would be right there. So that's how you show that. And now we're going to be finding the vertex, which is the minimum or maximum, the like end bit, the tip of your thing. So to find the vertex, you're just going to plug your axis of symmetry into your equation, like so. So I changed it from y equals x squared minus 2x minus 3 to y equals 1 squared minus 2 times 1 minus 3. And I simplify that to get y equals 1 minus 2 minus 3. So y equals negative 4. So the vertex, this is just the y of the vertex, this bit. So your vertex in its whole is 1, negative 4. So that, I'll show you what that looks like on here. See? So you've got 1 and then negative 4. So that is your vertex. That is the tip. It does not get any lower than that. Now to find the X-Intercepts. So you have your equation, and you're going to, instead of making it y equals, you're going to make it equals 0. Because that is how you factor. Or that's how you find your X-Intercepts. And then you're going to factor your equation. I factored mine into the product of two binomials. There are lots of different methods to do this if it doesn't work for the binomials. I'm not going to go over them because they're really long and annoying to do. So I have x plus 1 times x minus 3 because 1 times negative 3 equals negative 3, which is this number. And 1 plus negative 3 equals negative 2, which is this number. So when you're doing your binomials, you're going to have it, when you multiply it together, it's going to get this number. When you add it together, it's going to get this. Okay, so your x can either be negative 1 or 3, because if you have negative 1 plus 1 is 0, or positive. The fire alarm just went off in my house. That's kind of crazy. I'm going to keep going. So we have x minus 3. So if x equaled 3, 3 minus 3 equals 0. So your x-intercepts are going to be negative 1 and 3. So that is where your graph touches the 0 on the y-axis. It's 0 on the y-axis, then that's your x-intercept. So see, you have 1 and then -3. And trick to know whether or not you're right on this one. If your vertex doesn't look like in the center of these two, then you probably have it wrong, just so you know. Okay, so that is how, here, let me show you the finished equation one last time. Very nice. Okay, so that is how to find the axis of symmetry, vertex, and x-intercepts of a parabola in ax squared plus bx plus c form. Thank you for watching this. I hope it helped you. If it didn't and you need extra help, just email me at the email in the description. I can totally try and help you. Also, if you want more math videos, if there's something that you're confused on, just go ahead and email me about that too, and I will most definitely put it up. Okay? Thank you for watching, and goodbye.